40,000 pounds per square inch. That is the bite force of the Megalodon shark, 3 times stronger than a Tyrannosaurus rex, enough to crush a car like cardboard. For 14 million years, nothing in the ocean could challenge it. Then 3.6 million years ago, it vanished. Or did it? 95% of our oceans remain unexplored. The coelacanth was declared extinct for 66 million years, until one was pulled from the sea in 1938. What else is hiding down there? What if the monsters never left? But before we begin, do not forget to subscribe, and if you truly enjoy these videos, please leave a like. Let us begin. Imagine standing on the edge of a boat in the middle of the Pacific Ocean. The sun hangs low on the horizon. The water stretches in every direction as far as the eye can see. Below you is darkness, miles of darkness. And somewhere down there in that endless black abyss lurks something ancient. Something that was never supposed to die out. Something with jaws wide enough to swallow a car whole and teeth the size of your hand. What if the Megalodon shark never went extinct? What if that 60-foot nightmare is still down there hunting whales and patrolling the depths, waiting for something large enough to be worth its attention? And here is the question that will haunt you by the end of this video. What if Megalodon is not the only creature we wrote off too soon? What if the monsters we thought were gone are still out there hiding in plain sight in forests we have never fully explored and waters we have barely touched? Today we're going to dive into the dark waters of extinction and survival. We will examine the Megalodon, the largest predatory shark to ever exist, and ask what our oceans would look like if it still ruled the seas. We will travel to the misty highlands of Scotland, where something enormous has been spotted in a cold, dark lake for over 1,500 years. We will trek through the frozen peaks of the Himalayas searching for the legendary Yeti. We will hunt through the wilderness of Tasmania for an animal science declared dead decades ago but which people keep seeing. And we will discover that sometimes science gets it wrong. Sometimes the things we thought were gone come back. Sometimes the monsters are real. This is not a story about fantasy creatures and campfire tales. This is about real animals that once walked. This earth breathed the same air and swam the same oceans. Animals that left behind bones and teeth and evidence of their existence. Animals that in some cases vanished so recently that your grandparents might have seen them. And in other cases, animals that we were so certain had disappeared millions of years ago that their rediscovery shocked the entire scientific world. The ocean covers 71% of our planet. We have explored less than 5% of it. The deep sea remains the largest unexplored territory on Earth, more mysterious than outer space, in many ways. When we send probes to Mars, we can see the entire surface. When we look at the ocean floor, we are staring into a void that swallows light and keeps its secrets close. Every year we discover new species living in those depths. Creatures so bizarre they look like they were designed by a fever dream. Transparent fish with teeth like needles. Worms that live on volcanic vents where the water would boil you alive. Sharks that glow in the dark. If these things can hide for millions of years only to suddenly appear on a marine biologist camera, what else is down there? The Megalodon was the ultimate apex predator. Nothing came close. This was not just a big shark. This was a god of the ocean, a biological weapon designed by evolution to dominate every ecosystem it entered. At 60 feet long, it was 3 times the length of the largest great white sharks alive today. Its jaws could open wide enough to swallow a small car, and they were lined with 276 teeth, each one serrated and sharp, designed to slice through whale blubber and shatter bone. Scientists estimate its bite force at up to 40,000 pounds per square inch. The most powerful bite of any creature that ever lived. A Tyrannosaurus rex maxed out at around 12,000. The Megalodon made the king of the dinosaurs look like a gentle nibbler. For roughly 14 million years, this monster dominated the world's oceans. From the early Miocene through the Pliocene epochs, Megalodon hunted baleen whales, dolphins, seals, sea lions, giant sea turtles, and even other sharks. It was the unquestioned ruler of the marine food chain. No competition, no predators. Just endless hunting across warm tropical and subtropical seas that stretched around the globe. Megalodon fossils have been found on every continent except Antarctica. This was a truly global predator comfortable in the Atlantic, Pacific, and Indian Oceans. Wherever there was warm water and large prey, the Megalodon followed, and then around 3.6 million years ago it vanished. The fossil record goes silent. No more teeth washing up on shores, no more vertebrae found in sediment, no more bite marks on whale bones. The ocean emperor was gone, and the seas would never be the same again. But here is where the story gets interesting. Here is where science meets speculation and evidence meets imagination. What if we are wrong about when it died? What if Megalodon did not go quietly into that dark prehistoric night? What if somewhere in the unexplored 95% of our oceans, a population of these ancient sharks found a way to survive? This question has haunted marine biologists, cryptozoologists, and anyone who has ever stared into the ocean and felt that primal shiver of fear. The internet is full of supposed sightings, grainy videos showing enormous fins breaking the surface, photographs of teeth that look suspiciously fresh. Documentary after documentary has explored the possibility that Megalodon is still alive, waiting in the deepest trenches of the ocean for its moment to resurface. Scientists are quick to dismiss these claims. They point out that Megalodon was a warm water coastal shark that needed shallow nursery areas to raise its young. They note that its primary food source, mid-sized baleen whales, largely went extinct or migrated to colder waters. They explain that we would see evidence massive bite marks on modern whales. Corpses washing up on beaches increased great white shark avoidance of certain areas. A 60-foot apex predator cannot hide forever. It would need to eat roughly 2,500 pounds of food every single day. That is 6.5 bottlenose dolphins worth of meat daily. Such a creature would leave evidence. And yet the ocean is vast beyond human comprehension. The Mariana Trench alone plunges nearly 36,000 feet below the surface. We have sent fewer people to its depths than we have sent to the moon. What lives? Down there? What survives in the crushing darkness miles beneath the waves? We know giant squid exist, creatures that were considered myths until relatively recently. We know the coelacanth swims off the coast of Africa, a fish believed to have gone extinct with the dinosaurs until one was pulled from the sea in 1938. We know that new species of whales and sharks are still being discovered, animals large enough that they should have been noticed centuries ago. The truth is more complicated than simple yes or no answers. The truth requires us to examine the evidence, consider the science, and understand what extinction actually means. Because extinction is not just about whether a creature is alive or dead. Extinction is about ecosystems and food chains, and the delicate balance that keeps our planet functioning. When Megalodon disappeared, it created a vacuum at the top of the marine food chain. That vacuum changed everything. Today we are going to explore that change. We are going to examine what the world looked like when Megalodon ruled, and what it looks like now without its massive shadow darkening the waters. We are going to ask what would happen if that shadow returned. And along the way, we are going to discover that Megalodon is just one chapter in a much longer story. A story about creatures that refuse to stay dead, about sightings that defy explanation, and about the thin line between myth and reality. The monsters are waiting. Some of them in the depths of the ocean, some in ancient lakes surrounded by mist, some in frozen mountain peaks where the snow never melts, and some in forests so dense that sunlight barely reaches the ground. They're waiting for us to find them, or perhaps they are waiting for us to stop looking so they can emerge from the shadows. Welcome to a world where extinction is not always permanent. Welcome to the hunt for the monsters that never left. Let us begin with the greatest of them all. Let us begin with Megalodon, Chapter 2. Megalodon, the Ocean Emperor. To understand what the world lost when Megalodon disappeared, we need to understand what Megalodon actually was. Not the movie monster version, not the exaggerated creature of internet hoaxes and mockumentaries. The real animal, the actual biological entity that terrorized our oceans for 14 million years. Because the truth is more terrifying than any fiction Hollywood could produce. Megalodon, officially known as Otodus megalodon, was not just a bigger version of the great white shark. That is a common misconception, one that persists because Megalodon teeth resemble enlarged great white teeth. For decades, scientists believed these two sharks were closely related, perhaps even direct ancestors and descendants. Modern genetic analysis and fossil evidence have proven this wrong. Megalodon belonged to a completely different lineage of sharks, the Otodontidae family, which split from the ancestors of great whites tens of millions of years before. Either species existed in their modern forms. Think of it this way. Megalodon was to great whites what a lion is to a house cat. Same general body plan, same basic hunting strategy, but operating on an entirely different scale with capabilities that dwarf anything alive today. The great white shark is an incredible predator in its own right. An 18-foot great white weighing 2 tons is one of the most feared animals on the planet. Now imagine something 3 times longer weighing up to 50 times more with jaws that could crush a small boat like cardboard. The name Megalodon means giant tooth in Greek, and those teeth are the primary evidence we have of its existence. Sharks are cartilaginous fish. Their skeletons are made of cartilage, not bone. Cartilage does not fossilize well. It breaks down and disappears, leaving almost no trace. But teeth are different. Teeth are coated in enamel, a hard mineral substance that preserves beautifully. And Megalodon went through a lot of teeth. Like all sharks, it constantly shed and replaced its dental arsenal. A single Megalodon might have produced and lost 20,000 teeth over its lifetime. That is why we find them everywhere. Megalodon teeth have been discovered on every continent except Antarctica. Beachcombers in Florida find them washing up after storms. Divers off the coast of North Carolina pull them from underwater gravel beds. They turn up in Morocco, Australia, Japan, England, Indonesia, and dozens of other locations. Each tooth is a masterpiece of evolutionary engineering. The largest specimens measure over 7 inches from root to tip. They are thick, robust, built for grabbing and crushing rather than slicing and slipping through flesh like great white teeth. The serrations are smaller and more numerous, designed to saw through whale blubber and hold on to struggling prey. But teeth alone do not tell the whole story. We have also found vertebrae. Megalodon vertebrae are massive dinner plate-sized discs of calcified cartilage that somehow survived the fossilization process. By analysing growth rings in these vertebrae similar to tree rings, scientists have determined that megalodons were slow-growing, long-lived animals. A typical individual might live 40 to 100 years, reaching sexual maturity only after 25 years. This is important for understanding why they went extinct. Long-lived, slow-reproducing animals are vulnerable to environmental change. They cannot adapt quickly. They cannot bounce back from population crashes. So what did this monster look like? Here is where science gets speculative. Without a complete skeleton, we cannot know for certain. For years, artists depicted Megalodon as a scaled-up great white, with the same streamlined torpedo shape and familiar colouring. Recent research suggests this was probably wrong. Based on tooth morphology and what we know about related species, Megalodon likely had a flatter snout, shorter pectoral fins and a blockier maw. Robust body plan. Some scientists suggest it resembled a sand tiger shark more than a great white. Others propose it looked unlike any shark alive today, a unique body form adapted for hunting the largest prey in the ocean. One thing we know for certain is its hunting strategy. Megalodon fossils appear alongside fossils of its prey, primarily baleen whales. Many of these whale fossils show distinctive marks: grooves and gouges in flipper bones, shattered tail vertebrae, crushed skulls. The pattern tells a story. Megalodon did not attack whales the way great whites attack seals. Great whites typically go for soft, vulnerable areas, the belly, the throat. Megalodon attacked the hard parts. It bit through flippers to immobilize its prey. It crushed tailbones to prevent escape. It then delivered killing bites to the head and vital organs of its already crippled victim. This suggests a level of strategic thinking that we see in only the most advanced predators today. Orcas use similar techniques when hunting large whales. They work together to exhaust their prey, then target the fins and flukes to slow it down. Megalodon apparently figured this out on its own, operating as a solitary hunter that could take down animals larger than itself through careful targeted violence. Not mindless aggression, calculated destruction. The bite force estimates are almost impossible to comprehend. Studies using computer models of Megalodon jaws based on fossil teeth and the few vertebrae we have suggest a bite force between 24,000 and 40,000 pounds per square inch. For comparison, a human bite maxes out around 160 pounds per square inch. A great white reaches about 4,000. An alligator, one of the strongest biters alive today, hits 16,000. The Megalodon was literally in a league of its own. That kind of force could shatter the bones of any animal in the ocean. Whale ribs would splinter like dry twigs. Dolphin skulls would collapse instantly. Even the thick armoured hides of prehistoric sea turtles would offer no protection. When Megalodon bit down, nothing survived. Nothing escaped. The ocean must have been a place of absolute terror for anything large enough to be worth eating. And Megalodon ate constantly. A warm-blooded apex predator weighing up to 60 tons needs enormous amounts of energy. Scientists estimate daily food requirements of around 2,500 pounds. That is more than most adult humans weigh every single day. A megalodon could not afford to rest, could not afford to miss too many meals. It would have been in constant motion patrolling its territory, searching for prey, consuming everything it could catch. This puts the myth of deep-sea hiding in perspective. The deep ocean is a food desert. There is not enough prey down there to sustain a population of giant predators that need thousands of pounds of food daily. Megalodon was a creature of the continental shelves, the warm, shallow waters, where life congregates in abundance. It needed those nursery areas for its young. Baby megalodons were born live, not hatched from eggs, and they were born big. Newborn megalodons were likely 6 to 12 feet long, larger than adult bull sharks. They spent their early years in protected coastal waters feeding on fish and small marine mammals before graduating to whale hunting as adults. This life history makes megalodon survival incredibly unlikely. Those coastal nursery areas no longer exist in their original form. Sea levels have changed, ocean temperatures have dropped. The ecosystems that supported megalodon reproduction have fundamentally transformed. Even if adult megalodons somehow survived in the open ocean, they would have nowhere to breed, nowhere to raise their young. And without reproduction, survival is just delayed extinction. But let us imagine for a moment that none of this mattered. Let us imagine that somewhere, somehow, a population of megalodons found a way to adapt. Perhaps they followed their whale prey into deeper waters. Perhaps they developed the ability to survive in colder temperatures. Perhaps they found alternative food sources in the unexplored abyss. What would our oceans look like with these monsters still patrolling the depths? The answer is terrifying and fascinating in equal measure. Because Megalodon was not just a predator, it was a keystone species. Its presence shaped entire ecosystems, determined which species thrived and which struggled, kept the balance of marine life in a configuration we cannot even imagine today. When Megalodon disappeared, that balance shattered. New species rose to fill the vacuum. Old patterns of life were replaced by new ones. The oceans we know today are literally built on the absence of Megalodon. What happens when you put the missing piece back into a puzzle that has already been completed? What happens when the emperor returns to a kingdom that learned to rule itself? The answer is chaos. Beautiful, terrible chaos that would reshape everything we know about the sea. But before we explore that hypothetical future, we need to understand the past. We need to know why Megalodon really went extinct. Because the story is not as simple as scientists once believed. The death of the ocean emperor was a tragedy millions of years in the making. A perfect storm of climate change competition and cosmic bad luck that wiped the most successful predator in marine history from the face of the earth. Chapter 3. What killed the king? For an animal that dominated the oceans for 14 million years, Megalodon died remarkably fast. Not in geological terms, of course. A million years might seem like an eternity to us, but in the grand sweep of evolutionary time it is the blink of an eye. One moment Megalodon was everywhere. The next, it was gone. The fossil record shows a gradual decline starting around 4 million years ago, followed by complete disappearance roughly 3.6 million years ago. Something killed the king of the ocean, and scientists have spent decades trying to figure out exactly what. The traditional explanation focused on climate change. Around 5 million years ago, Earth entered a cooling phase. Global temperatures dropped, ice sheets expanded at the poles, sea levels fell as water became locked in glaciers. The warm, shallow seas that Megalodon called home began to shrink. Tropical waters retreated toward the equator. Temperate zones expanded. The world was becoming a colder, harder place for a shark that had evolved in greenhouse conditions. This theory made sense. Megalodon was almost certainly an endothermic or warm-blooded shark. Recent studies of chemical isotopes in Megalodon teeth suggest the animal maintained a body temperature roughly 7 degrees Celsius, warmer than the surrounding water. This metabolic trick allowed Megalodon to be faster and more active than cold-blooded sharks, but it came at a cost. Maintaining that elevated temperature required enormous amounts of energy. In a cooling world with shrinking food supplies, that energy became harder and harder to find. But climate change alone does not explain the extinction. Other large sharks survived the same cooling events. Whale populations actually increased after Megalodon disappeared. Something else was happening. Something more specific to Megalodon and its ecological niche. Enter the competition theory. Around 4 million years ago, a new predator appeared in the world's oceans. The great white shark Carcharodon carcharias evolved serrated teeth and spread rapidly across the globe. Great whites were smaller than Megalodon, much smaller, but they were also faster, more maneuverable, and perfectly adapted to the changing ocean conditions. They could hunt in cooler waters, they could survive on smaller prey, and critically, they began targeting the same food sources that Megalodon depended on. Robert Boesnecker, a paleontologist at the College of Charleston, has spent years studying this transition. His research suggests that great whites arrived in force around 4 million years ago, spreading worldwide by 3.6 million years ago. The timing is not coincidental. Megalodon disappeared at almost exactly the same moment great whites achieved global distribution. Boesnecker believes the two events are directly connected. The great white did not kill Megalodon directly. A 15-foot great white is no match for a 60-foot Megalodon, but great whites outcompeted Megalodon for resources. They ate the same mid-sized prey, they occupied the same ecological space, and they did it more efficiently. Think of it like a business competition. Megalodon was a massive corporation with enormous overhead costs. It needed huge amounts of resources to operate. Great whites were lean startups, lower overhead, more adaptable, better able to survive when times got tough. In a world of shrinking resources, the efficient competitor wins. Megalodon simply could not eat enough to sustain itself while competing with these smaller, more nimble rivals. But even this does not tell the complete story. The extinction was more complex, involving multiple factors that combined into a perfect storm of destruction. Consider the prey base. Megalodon primarily hunted baleen whales, specifically mid-sized species like cetotheres, that lived in warm coastal waters. Around the time Megalodon declined, these prey species also began disappearing. Some went extinct entirely, others evolved larger body sizes or migrated to colder waters following the retreating warmth. The buffet that Megalodon had enjoyed for millions of years was closing down, and then there were the orcas. Killer whales as we know them today evolved during this same period. These intelligent pack-hunting predators represented something Megalodon had never faced before coordinated group attacks by clever mammals. Adult Megalodons were probably safe from orca predation, but their babies were not. Remember those nursery areas, the shallow coastal waters where juvenile Megalodons grew to maturity? Those same waters were now patrolled by roving pods of intelligent predators, working together to take down young sharks. This created a demographic nightmare. Adult Megalodons were struggling to find food. Juveniles were being picked off by orca packs. Breeding populations crashed. Each generation was smaller than the last. And unlike fast reproducing fish, Megalodon could not bounce back quickly. 25 years to reach sexual maturity, slow reproduction rates, long gaps between generations. By the time the species might have adapted to new conditions, there were not enough individuals left to sustain a viable population. The killing blow may have come from geology itself. Around 3 million years ago, the Isthmus of Panama rose from the sea, connecting North and South America. For the first time in tens of millions of years, this land bridge fundamentally altered. Ocean circulation. The Gulf Stream weakened. Nutrient-rich upwellings that had supported abundant marine life along certain coastlines dried up. Ecosystems that had existed for millions of years collapsed in geological moments. Megalodon was caught in the middle of all this change. Its habitat was shrinking, its food was disappearing, its young were being hunted, its competitors were thriving, and the very structure of the oceans was transforming around it. Any one of these factors might have been survivable. Together they were fatal. Recent research has narrowed down the extinction window with remarkable precision. Using advanced dating techniques on Megalodon fossils from around the world, scientists now believe the species disappeared between 295,000 and 215,000 years ago. That is much more recent than previously thought. It places Megalodon extinction well into the Pleistocene epoch. Some of our human ancestors were already walking the Earth when the last Megalodon died. Homo erectus might have witnessed the final chapters of this ancient predator's story, even if from a safe distance on shore. But here is where things get interesting. The extinction date is not certain. There is always uncertainty in fossil dating. Some specimens may have been contaminated or moved from their original locations over geological time. A handful of megalodon teeth have been dated to much more recent periods, though these dates are highly controversial. In the 1950s, 2 megalodon teeth dredged from the deep Pacific were dated to only 11,000 and 24,000 years old. If accurate, that would mean megalodons survived the end of the last ice age. They would have been swimming the oceans when humans were building the first permanent settlements. Most scientists dismiss these dates as errors. The teeth were probably older specimens that had been chemically altered over time, giving false readings. But the controversy highlights an important point. We cannot know with absolute certainty when any species went extinct. The last fossil is not the last individual. There is always a gap between the final physical evidence and the actual moment of extinction. For most species, this gap is relatively short. For others, especially marine species that rarely fossilize it, could be thousands or even millions of years. Consider the coelacanth. This primitive fish was known only from fossils dating back hundreds of millions of years. Scientists were absolutely certain it had gone extinct with the dinosaurs 66 million years ago. Then, in 1938, a living coelacanth was pulled from the ocean off South Africa. Decades of scientific certainty evaporated in an instant. If we could be so wrong about the coelacanth, what else might we be wrong about? The counter-argument is compelling. Megalodon was not like the coelacanth. Coelacanths are small, secretive fish that live in deep, rocky caves. They do not interact with surface ecosystems. They leave no evidence of their presence unless caught directly. Megalodon was a 60-foot apex predator that ate whales. Its presence would be impossible to hide. We would see bite marks on whale carcasses. We would find freshly shed teeth. We would have documented encounters with fishing vessels and research ships. None of this evidence exists. No verified megalodon sightings in modern times. No fresh teeth. No bite marks that cannot be explained by other predators. The documentary that aired on Discovery Channel in 2013 claiming to prove megalodon survival was fiction. The scientists were actors. The photographs were faked. The entire thing was manufactured entertainment with a small disclaimer that most viewers missed. Yet people want to believe. They need to believe that somewhere in the unexplored vastness of our oceans, this magnificent monster still hunts. Perhaps that says more about us than about Megalodon. We mourn the loss of such a creature even though its existence would terrify us. We dream of its return even though that return would fundamentally alter our relationship with the sea. What would that altered relationship look like? What would happen if Megalodon came back not through survival, but through some miraculous return? The question is not just academic. As we will see, the world Megalodon left behind has changed so dramatically that its return would create chaos on a scale we can barely imagine. The king is dead. But what if the king could rise again? What would his kingdom look like after 3 million years without a ruler? Chapter 4. A World with Megalodon. Close your eyes for a moment. Imagine standing on the deck of a whale watching boat off the coast of California. The Pacific stretches to the horizon. Grey whales surface nearby, spouting mist into the salt air. Children point and gasp. Parents take photographs. Everyone is smiling. Now imagine what happens when a shadow rises from beneath those whales. A shadow the length of a school bus. A shadow with jaws that can crush bone like chalk, and an appetite that knows no bounds. The screaming starts before anyone consciously recognizes what they are seeing. Primal terror hardwired into our DNA by millions of years of evolution kicks in before rational thought can process the image. The grey whale that was peacefully feeding moments ago is dragged under in an explosion of blood and foam. 60 tons of prehistoric fury erupts through the surface, jaws wide enough to swallow a motorcycle chomping down on blubber and muscle. The boat rocks violently in the shockwave. Someone falls overboard, and the Megalodon is still hungry. This is what our oceans would look like if Megalodon never went extinct. Not a peaceful coexistence between ancient predator and modern life, but complete and total restructuring of marine ecosystems from the bottom up. Everything we know about the ocean would change. Everything we take for granted about maritime activity would have to be reconsidered. The sea would once again become what it was for most of human history, a place of terror that we approach with caution and fear. Let us start with the most obvious impact. Megalodon would decimate whale populations. This is not speculation. Whales were Megalodon's primary food source for millions of years. The only reason whales achieved their current sizes and numbers is because Megalodon is not around to eat them. Blue whales, the largest animals ever to exist, evolved after Megalodon disappeared. Without predation, precious smaller whales could become larger. Filter-feeding giants could grow to 100 feet long and 200 tons. If Megalodon returned, those giants would become prey. A single Megalodon eating 2,500 pounds of food per day would consume roughly 50 adult humpback whales per year. Now imagine a viable breeding population of Megalodons. Even a small population of a few hundred individuals would be taking 50,000 whales annually. Current global whale populations cannot sustain that kind of predation. Species that took decades to recover from whaling would crash within years. The great whale conservation success stories of the late 20th century would become great whale extinction events of the 21st. But the cascade effects would extend far beyond whales themselves. Whales play crucial roles in marine nutrient cycling. Their feces fertilize surface waters, feeding phytoplankton blooms that generate oxygen and absorb carbon dioxide. When whales die, their bodies sink to the ocean floor, creating whale-fall ecosystems that support hundreds of species for decades. Remove a significant percentage of whales and these nutrient pathways collapse. Phytoplankton populations decline. Fish that feed on phytoplankton decline. Seabirds that feed on fish decline. The entire ocean food web begins to unravel. Scientists call this a trophic cascade. Remove a top predator and the effects ripple downward through every level of the ecosystem. But Megalodon would not be removing prey and disappearing. It would be adding a new top predator above everything else currently in the ocean. The cascade would work in reverse. Whale populations crash. Krill populations potentially explode with fewer whales to eat them. Krill explosions might seem beneficial, but they consume resources that other species need. Competition intensifies at every level. Species that had achieved stable relationships over millions of years are suddenly thrown into chaos. Great white sharks would face the most immediate threat. These are Megalodon's closest ecological competitors. In a world with Megalodon, great whites would need to either adapt or die. They might shift to smaller prey items that Megalodons ignore. They might migrate to colder waters where Megalodons cannot follow. Or they might simply be driven extinct, outcompeted, and occasionally eaten by their giant distant cousins. The ocean's terrifying modern predator would become just another victim of an even more terrifying ancient one. Orcas present an interesting question. Killer whales are among the most intelligent predators on Earth. They hunt in coordinated pods, communicate with sophisticated vocalizations, and pass hunting techniques down through generations. Would orcas be able to coexist with Megalodon? The answer is probably yes, but only by dramatically changing their behavior. Orcas might learn to avoid Megalodon territory. They might develop specific defense strategies for when Megalodons approach. Or they might target juvenile Megalodons the way they may have 3 million years ago. The dynamic would be fascinating to observe if it were not so terrifying to contemplate. Human maritime activity would transform overnight. Consider commercial fishing. Much of the world's protein comes from the ocean, harvested by fleets that operate in the same waters. Megalodons would patrol. Fishing boats are not designed to survive attacks from 60-foot predators. Nets and lines attract exactly the kind of large prey that Megalodons hunt. The smell of fish blood in the water would be an irresistible dinner bell. Commercial fishing in warm and temperate waters would become essentially impossible. The economic impact would be measured in hundreds of billions of dollars annually. Shipping would face similar challenges. Container ships and oil tankers are large enough to probably survive a Megalodon encounter, though the psychological impact on crews would be severe. But smaller vessels, cruise ships, ferries, research vessels would be operating in constant danger. Insurance rates would skyrocket. Certain shipping lanes might have to be abandoned entirely. The global economy that depends on maritime trade would need to adapt to a new era of ocean terror. Recreation would change most dramatically of all. Swimming, surfing, diving, sailing all would carry risks that most people would find unacceptable. Beaches would need to be evaluated for Megalodon activity. Shark nets that barely work against great whites would be useless against something 3 times larger. Tourism industries built around ocean access would collapse in coastal communities worldwide. Hawaii would lose visitors. Florida would lose residents. The Mediterranean would become a place people admire from shore rather than swim in. But here is the strange thing. Despite all this terror, despite all this disruption, humans would adapt. We always do. We would develop new technologies to detect and deter Megalodons. We would build stronger boats. We would create protected swimming areas. We would study megalodon behavior patterns and learn when and where they are most active, and eventually, inevitably, we would start to see them differently. Megalodon would become the ultimate symbol of nature's power. The greatest predator our planet has ever produced still prowling the depths. Conservation efforts that currently focus on saving sharks from humans would need to figure out how to protect humans from sharks while also ensuring megalodon's long-term survival. Because despite the damage they would cause, megalodons would also become the most awe-inspiring animals on Earth. National parks in the ocean, megalodon research expeditions, submarine tours that keep safely behind reinforced glass while 60-foot sharks swim past. We would learn from them. Their biology would tell us about warm-bloodedness in fish, about gigantism in marine predators, about the limits of what evolution can produce. We would study their hunting patterns and discover things about whale behavior we never could have observed otherwise. We would track their migrations and understand ocean currents in new ways. Every megalodon would be a living window into our planet's past and a key to understanding its future. The horror and the wonder would exist side by side, just as they did for millions of years before Megalodon disappeared. Just as they do today with great whites and orcas and crocodiles and tigers. Humanity has never lived in a world without dangerous predators. We have only lived in a world without the most dangerous predator of all. Megalodon's return would remind us of something we have forgotten. The ocean is not ours. It never was. We are visitors in a realm that belongs to things older and more powerful than we can imagine. But Megalodon is not coming back. The Ocean Emperor is dead. His throne sits empty. And the kingdom has changed so much that even if he could return, there might not be a place for him anymore. The whales he hunted have evolved. The waters he swam have cooled. The world has moved on. Which brings us to a different kind of question. If Megalodon is truly gone, are there other monsters waiting in the shadows? Other creatures that science declared extinct, but that keep appearing in sightings and stories? What about the beast that supposedly lurks in a cold Scottish lake? What about the legendary creature of the Himalayas? What about the animals that we know once existed, and that some people swear still do? The Megalodon story is just the beginning. The real hunt is about to begin. Chapter 5. The Beast of Loch Ness, Scotland. The highlands rise green and ancient beneath perpetual grey skies. Mist crawls through valleys that have not changed in 10,000 years, and there in the heart of this mysterious landscape lies Loch Ness, 23 miles long, 750 feet deep at its deepest point, cold, dark, and according to 1,500 years of reported sightings home to something enormous. The Loch Ness Monster is perhaps the most famous cryptid in the world, more famous than Bigfoot or the Yeti, more culturally significant than any other creature that supposedly exists but cannot be proven. Nessie, as the locals affectionately call it, has become a symbol of mystery itself. The idea that somewhere in our thoroughly mapped and catalogued world there might still be dragons waiting to be discovered. But unlike Megalodon, the Loch Ness Monster has never been proven to exist at all. There are no fossils, no DNA samples, no verified photographs despite nearly a century of investigation and millions of tourists with cameras. The scientific consensus is clear. There is no monster in Loch Ness. The sightings can be explained by waves logs, floating debris, swimming deer, and the occasional deliberate hoax. Case closed. Or is it? Let us start with what we actually know. Loch Ness was formed during the last ice age approximately 10,000 years ago. Before that, the entire area was covered in glaciers miles thick. Whatever lives in the loch arrived after the ice melted, either swimming up from the sea through the River Ness or being introduced by humans. The lake is cold, averaging around 5 degrees Celsius. It is murky with visibility often measured in feet rather than yards. The dark brown colour comes from peat that washes down from surrounding hills. If you wanted to design a body of water specifically to hide large creatures, Loch Ness would be an excellent choice. The first written account of a monster in the area dates to the 6th century. According to the Life of St Columba, written around 600 AD, the Irish monk Columba encountered a beast in the River Ness in the year 565. The creature had reportedly attacked and killed a swimmer. When it approached another man in the water, Columba commanded it to go back and the monster obeyed. This story established the basic template for Nessie encounters that would follow for centuries. A large aquatic creature, aggressive or at least threatening behaviour, a sense that something ancient and powerful lurked beneath the water. For over 1,000 years after Columba, occasional reports emerged from the loch. Local legends spoke of water horses and kelpies, supernatural creatures that could drown unwary travellers. These stories were common throughout Scotland and Ireland, but the ones associated with Loch Ness seemed to carry extra weight. Something about that deep dark water invited belief in monsters. Then came 1933, the year Nessie became a global phenomenon. In April of that year, a local couple named John and Aldi Mackay claimed to see an enormous creature creating a tremendous disturbance in the water. The Inverness Courier published their account and used the word monster in the headline. Within months, the story had spread around the world. Tourists began flooding into the Scottish Highlands. Newspapers offered rewards for photographs. The hunt for Nessie had begun in earnest. The famous surgeon's photograph appeared in 1934. It showed what appeared to be a long neck and small head, rising from the water, exactly what you would expect from a surviving plesiosaur. Robert Kenneth Wilson, a London physician, claimed to have taken the picture while driving along the lochshore. The Daily Mail published it on their front page. For 60 years, the surgeon's photograph was considered the best evidence for Nessie's existence. Scientists analysed it, believers treasured it, skeptics struggled to explain it away. In 1994, the truth finally emerged. The photograph was a hoax. A man named Christian Sperling confessed on his deathbed that he and his stepfather, Marmaduke Wetherell, had created the monster using a toy submarine fitted with a sculpted head. Wetherell had been hired by the Daily Mail to find the monster. When his initial evidence was debunked as hippopotamus footprints made with an umbrella stand, he decided to create better evidence. Wilson the physician was brought in to lend credibility. The entire thing was a prank that accidentally became one of the most influential photographs in cryptozoology history. But here is where Nessie differs from most hoaxes. The surgeon's photograph was fake, but the sightings did not stop when it was debunked. People continued to report seeing something in Loch Ness. Sonar surveys detected large moving objects. Underwater cameras captured strange shapes. The monster refused to die even when its most famous portrait was exposed as a lie. The plesiosaur theory remains the most popular explanation among believers. Plesiosaurs were marine reptiles that lived during the age of dinosaurs. They had long necks, small heads, 4 paddle-like flippers, and bodies that could reach 40 feet in length. They look almost exactly like the classic descriptions of the Loch Ness monster. If a population of plesiosaurs had somehow survived for 66 million years, Loch Ness would be exactly the kind of isolated refuge where they might hide. The problems with this theory are numerous. Plesiosaurs were air-breathing reptiles. They would need to surface regularly. In a lake surrounded by roads and tourists with cameras, they would have been photographed clearly by now. Plesiosaurs were also cold-blooded animals adapted to warm Mesozoic seas. Loch Ness is barely above freezing. The metabolic challenges of survival would be immense, and perhaps most importantly, plesiosaurs were marine animals. They lived in salt water. Loch Ness is freshwater. While recent fossil discoveries have shown that some plesiosaurs could tolerate fresh water, the species that most closely resembles Nessie, descriptions were strictly oceanic. There is also the question of population viability. One plesiosaur would not survive for millions of years. You need a breeding population. Scientists estimate that minimum viable population sizes for large vertebrates range from at least 50 individuals and possibly hundreds. That many 40-foot reptiles surfacing to breathe, eating fish, reproducing and dying would leave abundant evidence. Bodies would wash up on shore, bones would accumulate at the bottom, DNA would be present in water samples. None of this evidence exists. In 2018 and 2019, a team led by Professor Neil Gemmell of the University of Otago conducted the most comprehensive environmental DNA survey of Loch Ness ever attempted. They collected over 200 water samples from throughout the loch and analysed them for genetic traces of every organism present. The results were fascinating. They found DNA from humans, dogs, sheep, deer, 3,000 different species in total, but no plesiosaur DNA, no unknown reptile DNA, no trace of any large animal not already known to science. What they did find in abundance was European eel DNA. Eels are common in Loch Ness. They migrate from the Sargasso Sea to live in European fresh waters and can grow to substantial sizes. The largest European eels on record exceed 5 feet in length and weigh over 60 pounds. In the murky waters of Loch Ness, an unusually large eel breaking the surface could easily be mistaken for something more exotic. Gemmell did not claim to have solved the mystery, but suggested that the giant eel hypothesis deserved serious consideration. The psychological explanations are equally compelling. Humans are pattern recognition machines. We evolved to see faces in clouds, threats in shadows, movement in stillness. This tendency served our ancestors well when actual predators lurked in the bushes, but it also leads us to see things that are not there, especially when we are primed to expect them. Thousands of people visit Loch Ness every year hoping to see the monster. Some of them will see exactly what they are looking for, even if what they actually see is a wave log or a swimming bird. There is also the matter of wishful thinking and expectation. When someone tells you a lake contains a monster, you look at that lake differently. Every ripple becomes suspicious, every shadow conceals potential mystery. The normal becomes strange simply because you expect strangeness. This is not stupidity or delusion. It is how human perception works. We see what we are prepared to see. And yet the sightings continue. Credible witnesses describe encounters that do not fit neat explanations. Sonar readings detect large moving objects that behave unlike anything known to inhabit the loch. Something in Loch Ness continues to defy our understanding, even if that something turns out to be nothing more than our own need for mystery. The Loch Ness Monster teaches us something important about the relationship between science and wonder. Science can test claims about what exists. It can prove that certain explanations are impossible, but it cannot kill the desire to believe in monsters. That desire lives in a different part of us than rational analysis. It connects us to our ancestors who huddled around fires and told stories about the things in the dark. It reminds us that despite our technology and our knowledge, we are still small creatures in a vast and incompletely understood world. Nessie is probably not real. The evidence overwhelmingly suggests a combination of hoaxes, misidentifications, and wishful thinking, but probably is not certainly. The loch remains dark and deep. The sightings continue. And somewhere in the human heart there will always be room for monsters. Speaking of monsters that might not be real, let us climb from the waters of Scotland to the frozen peaks of the Himalayas. Let us go looking for the abominable snowman. Chapter 6. Giants of the Forest. The Himalayas rise like a frozen wall between India and Tibet. Peaks pierce the sky at heights where the air is too thin to breathe. Glaciers grind slowly downward, carving valleys that humans have barely explored. And somewhere in that wilderness, according to centuries of local legend, walks something that should not exist. A creature standing 8 to 10 feet tall, covered in thick fur, walking upright like a man but built like a beast. The Yeti, the abominable snowman, the wild man of the mountains. In North America, the same legend takes a different form: Bigfoot, Sasquatch. A massive bipedal ape that roams the forests of the Pacific Northwest, leaving behind enormous footprints and terrifying encounters. Thousands of sightings have been reported from Washington state to Florida, from Canada to Mexico. Photographs and film footage circulate online. Footprint casts fill the collections of amateur researchers. Something is out there, say the believers. Something that science has not yet explained. Unlike the Loch Ness Monster, these creatures have a plausible evolutionary ancestor. Gigantopithecus blacki was a real animal, the largest ape that ever lived. Standing nearly 10 feet tall and weighing up to 660 pounds, this giant walked the forests of what is now southern China for almost 2 million years. It looked roughly like an enormous orangutan and probably lived a similar lifestyle, browsing on plants and fruits in dense subtropical forest. When Gigantopithecus disappeared around 215,000 to 295,000 years ago, it left behind only teeth and jawbones. No complete skeleton has ever been found. Could Gigantopithecus have survived? Could small populations have persisted in remote mountain forests, evolving over hundreds of thousands of years into the creatures we now call Yeti and Bigfoot? The theory is seductive. It connects modern mystery with ancient reality. It explains the consistent descriptions across cultures and continents, and it offers hope that somewhere in the vast wilderness that still covers much of our planet, a living fossil awaits discovery. The evidence, however, does not support the theory. Gigantopithecus was a forest-dwelling ape, adapted to warm subtropical conditions. It ate bamboo and fruit. It could not survive in the frozen Himalayas or the temperate rainforests of the Pacific Northwest. The climate change that killed it was a shift toward cooler, drier conditions, exactly the opposite of what these legendary creatures supposedly inhabit. Furthermore, Gigantopithecus was likely quadrupedal or semi-quadrupedal like modern orangutans. The bipedal striding walk described in Bigfoot sightings does not match what we know about Gigantopithecus anatomy. But the Yeti and Bigfoot myths do not depend on Gigantopithecus for their power. These legends existed long before Western scientists discovered the giant ape's fossils. Indigenous peoples throughout the Himalayas have told stories of the Yeti for centuries. Native American tribes across North America have legends of hairy giants living in the forests. The Steers Ales people of British Columbia speak of Saskets, a shape-shifting creature that protects the wilderness. The Lummi people have stories of Tizimeco's giants covered in hair who steal salmon from fishermen. These are not imported Western fantasies. They are ancient traditions rooted in generations of experience with the land. What could explain such widespread consistent legends? Several possibilities exist. The first is misidentification. Bears standing on their hind legs can look remarkably humanoid, especially in poor light or at a distance. Black bears, brown bears, and the Himalayan brown bear all overlap with Bigfoot and Yeti territory. Many supposed Yeti sightings have been attributed to bears, particularly a rare subspecies of brown bear found in the high Himalayas that has unusually light-coloured fur. In 2014, geneticist Brian Sykes at Oxford University conducted the most rigorous scientific analysis of alleged Yeti and Bigfoot hair samples ever attempted. He collected 30 samples from around the world, including hair attributed to Yetis from the Himalayas and Bigfoot from North America. Every single sample belonged to known animals. Most were from bears, horses, cows, dogs, and raccoons. 2 samples from the Himalayas matched DNA from an ancient polar bear, suggesting that an unusual bear hybrid might exist in the region, but no sample came from an unknown primate, not one. The Sykes study was devastating to believers, but it did not end the controversy. Critics pointed out that the samples he tested were selected by him and might not represent the best available evidence. They noted that hair samples are easily contaminated and that negative results prove only that those specific samples were not from unknown primates. The absence of evidence, they argued, is not evidence of absence. This is technically true, but it becomes less persuasive with each passing year. We live in an age of trail cameras and smartphones. Millions of people carry high-definition video cameras in their pockets at all times. Hunters and hikers deploy motion-activated cameras throughout forests that supposedly harbour Bigfoot populations. Satellite imagery covers nearly every square mile of the planet. If large bipedal apes were roaming the Pacific Northwest, we would have clear evidence by now. The fact that we do not speaks volumes. The Patterson-Gimlin film remains the most famous piece of Bigfoot evidence. Shot in October 1967 in Northern California, it appears to show a female Bigfoot striding across a riverbank. The creature walks with a smooth, confident gait, looking back over its shoulder at the camera before disappearing into the forest. For over 50 years, believers and skeptics have analysed every frame of this footage. Some claim it proves Bigfoot exists, others insist it shows a man in a gorilla suit. The truth is that the Patterson-Gimlin film cannot prove anything either way. The footage is too grainy, too brief, and too ambiguous to provide definitive answers. What it does prove is how desperately people want to believe. The film has been enhanced, stabilised, analysed, and debated endlessly. Entire careers have been built on studying those few seconds of shaky footage. And still we are no closer to knowing what Roger Patterson actually filmed that October afternoon. Footprints present similar problems. Thousands of supposed Bigfoot footprints have been cast in plaster over the decades. Some are obvious fakes, carved boards, or modified shoes pressed into soft ground. Others are more mysterious, showing anatomical details that would be difficult to fabricate. Dermal ridges similar to fingerprints have been identified on some casts. Flexible mid-tarsal breaks suggesting a foot structure different from humans appear in others. These details have convinced some researchers that at least some footprints are genuine, but footprints alone cannot prove the existence of an animal. Without a body, without DNA, without clear photographic evidence, footprints remain circumstantial at best, and the body has never appeared. No Bigfoot has ever been killed and examined by scientists. No bones have been recovered. No roadkill has been reported despite thousands of Bigfoot sightings occurring near highways and populated areas. For a population of large primates to exist, there must be hundreds, if not thousands of individuals. They must be born, live, reproduce and die. Where are all the bodies? The psychological explanation for Bigfoot sightings is more compelling than the biological one. Humans evolved alongside dangerous animals. Our ancestors survived by being vigilant, by seeing threats before those threats saw them. This hypervigilance remains encoded in our brains. We are primed to see faces in random patterns, to detect movement in peripheral vision, to interpret ambiguous stimuli as potential predators. In a forest full of shadows and sounds, this tendency can easily produce Bigfoot sightings. There is also the social dimension. Bigfoot believers form communities. They share stories, validate each other's experiences, and create frameworks for interpreting ambiguous events. Once someone becomes part of this community, they are more likely to interpret unusual experiences as Bigfoot encounters. Confirmation bias takes over. Evidence that supports the belief is accepted. Evidence that contradicts it is dismissed or explained away. None of this means that every Bigfoot witness is lying or delusional. People genuinely experience things they cannot explain. The question is whether those experiences reflect encounters with unknown primates or with the limitations of human perception. Given the complete absence of physical evidence, the latter explanation seems far more likely. But let us consider for a moment what it would mean if Bigfoot were real. An undiscovered species of great ape living in North America would be the biological discovery of the century. It would force us to completely revise our understanding of primate evolution and distribution. It would raise profound questions about how such a creature could have remained hidden for so long, and it would open up exciting possibilities for conservation and research. If Bigfoot exists, it almost certainly represents a relic population of some known primate lineage, perhaps a descendant of Gigantopithecus that somehow crossed the Bering Land Bridge during the Ice Ages, perhaps an unknown branch of the hominid family tree that split from our ancestors millions of years ago, perhaps something else entirely. The possibilities are tantalizing, even if the probability is vanishingly small. The search continues. Amateur researchers spend weekends in the forest deploying cameras, recording sounds, and hoping for that one definitive encounter. Scientists occasionally investigate when evidence seems particularly compelling, and people keep seeing things that they cannot explain. Whether those things are undiscovered apes or simply the products of human imagination remains an open question. From the frozen peaks of the Himalayas and the dense forests of the Pacific Northwest, let us travel now to another wilderness. A place where something was not supposed to exist but did. Where science declared an animal extinct and was proven wrong. Where the line between myth and reality blurred and then snapped. Let us go to Tasmania. Let us hunt for the tiger that refuses to die. Chapter 7. The Tasmanian Ghost. September 7th, 1936. Hobart Zoo, Tasmania. A keeper walks past a concrete enclosure, barely glancing at the animal inside. The creature paces back and forth as it has done for years, striped like a tiger, built like a large dog with a stiff tail and a pouch for carrying young. The last of its kind. That night temperatures drop unexpectedly. The animal is not given shelter. By morning it is dead. The thylacine, commonly known as the Tasmanian tiger, went extinct that day. Or did it? Because unlike Megalodon, unlike the Loch Ness Monster, unlike Bigfoot, the thylacine definitely existed. We have photographs. We have film footage. We have preserved specimens in museums around the world. We know exactly what this animal looked like, how it moved, what it ate, and where it lived. And according to hundreds of people who live in Tasmania, it is still out there. The thylacine was one of the strangest animals evolution ever produced. It was a marsupial, meaning it carried its young in a pouch like a kangaroo or koala. But it looked almost exactly like a placental wolf. Same body shape, same running gait, same hunting strategy. This is one of the most remarkable examples of convergent evolution in nature. Two completely unrelated lineages arriving at nearly identical solutions to the same ecological problem. If you saw a thylacine running through the bush, you would swear you were looking at a dog or wolf until you noticed the stripes and the backward opening pouch. Thylacines once ranged across mainland Australia and New Guinea as well as Tasmania. They were apex predators hunting wallabies and other medium-sized mammals. Then around 3,000 years ago, they disappeared from everywhere except Tasmania. The likely culprit was the dingo. When humans brought these wild dogs to Australia, they outcompeted thylacines for prey and possibly hunted them directly. Tasmania remained thylacine territory because dingoes never made it across Bass Strait. When European settlers arrived in Tasmania in the early 1800s, they found perhaps 5,000 thylacines living on the island. That population would not last long. Farmers blamed thylacines for killing sheep. Whether thylacines actually posed a significant threat to livestock is debatable, but the perception was enough. Bounty programs were established. The Van Diemen's Land Company began paying for thylacine skins in 1830. The Tasmanian government joined in 1888, offering £1 for adults and 10 shillings for pups. Over 2,000 bounties were paid before the program ended in 1909. But bounty hunting alone did not kill the thylacine. Habitat destruction played a major role as forests were cleared for farming. Disease may have contributed, with some evidence suggesting a distemper-like illness swept through remaining populations. Competition from introduced species, including dogs and foxes, added additional pressure. By the 1920s, sightings had become rare. By the 1930s, thylacines were effectively gone from the wild. The last confirmed wild thylacine was shot in 1930 by a farmer named Wilfred Batty, who discovered it in his chicken coop. Batty posed for photographs with the body a young male in good condition, with clearly visible stripes. The image has become iconic, representing humanity's capacity for destruction and our belated recognition of what we have lost. 6 years later, the last captive thylacine died in Hobart Zoo. The species was officially declared extinct in 1982. Except the sightings never stopped. Within years of the official extinction date, people began reporting thylacine encounters. Farmers saw striped animals crossing their fields at dusk. Motorists spotted creatures that looked like dogs but moved wrong, crossing roads in their headlights. Bushwalkers heard unusual calls in the forest sounds that matched archival recordings of thylacine vocalizations. The Tasmanian tiger, it seemed, refused to stay dead. In 1982, the same year the species was officially declared extinct, a parks and wildlife ranger named Hans Narding had an encounter that would change thylacine research forever. Narding was sleeping in his vehicle in a remote area of northwest Tasmania when he woke around 2 a.m. He shined his torch into the darkness and saw an animal standing 6 to 7 meters away, an adult male thylacine in excellent condition with 12 black stripes on a sandy coat. The animal watched him for several minutes before walking away into the forest. Narding was an experienced wildlife professional. He knew what he was looking at. His report was taken seriously enough that the Tasmanian Parks and Wildlife Service launched an intensive search of the area. For 2 years, teams scoured the bush looking for evidence. They found nothing. But Narding never wavered in his account. Until his death, he maintained that he had seen a living thylacine. Since then, hundreds of additional sightings have been reported. Some come from credible witnesses with backgrounds in wildlife biology or conservation. Others come from ordinary citizens who simply saw something they could not explain. The quality of sightings varies enormously. Many can be easily dismissed as misidentified dogs, foxes, or even large cats. Others are more difficult to explain. In 2021, Barry Brook, a conservation biologist at the University of Tasmania, published a groundbreaking analysis of thylacine sightings. He and his colleagues compiled over 1,200 reported observations from 1910 to the present, assigning each a reliability rating based on the credibility of the witness, the quality of the observation, and corroborating factors. Using statistical modelling, they estimated when the thylacine most likely went extinct. The results surprised everyone. According to Brook's analysis, the thylacine probably survived until at least the 1980s, and possibly as late as the 1990s or early 2000s. There is even a small statistical chance that thylacines persist today in the remote southwestern wilderness of Tasmania. This is not a fringe claim. This is peer-reviewed research published in a respected scientific journal. The thylacine may have survived for decades longer than anyone believed. The implications are profound. If thylacines were still alive in the 1980s, conservation efforts could potentially have saved them. Resources that were directed elsewhere might have made the difference between survival and extinction. The window of opportunity may not have closed in 1936, but decades later, when the species slipped quietly into oblivion without anyone noticing. Today, the search for surviving thylacines continues. Amateur researchers deploy trail cameras throughout Tasmanian wilderness. Professional scientists occasionally investigate when sightings seem particularly credible, and organisations like the Thylacine Awareness Group collect and analyse reports from the public. So far, no definitive evidence has emerged. No clear photographs, no verified DNA, no bodies, but the hope refuses to die, and that hope has spawned one of the most ambitious projects in the history of biology. Scientists are now attempting to bring the thylacine back from extinction. The TIGR lab at the University of Melbourne is leading efforts to de-extinct the thylacine using genetic engineering. The concept is straightforward, even if the execution is incredibly complex. Scientists have sequenced the complete genome of the thylacine from preserved specimens. They have identified the genetic differences between thylacines and their closest living relative, the fat-tailed dunnart, a tiny marsupial mouse. By editing dunnart DNA to match thylacine DNA, they hope to eventually create a living thylacine, or at least something very close to one. The project has attracted millions of dollars in funding and support from celebrities, including Leonardo DiCaprio and Paris Hilton. Proponents argue that bringing back the thylacine could help restore Tasmanian ecosystems and demonstrate technologies that might save other endangered species. Critics worry that de-extinction distracts from protecting species that are still alive, and that a resurrected thylacine would not truly be the same animal that went extinct. The ethical questions are complex. If we can bring back the thylacine, should we? What about other extinct species? Where do we draw the line? And most importantly, does de-extinction actually undo the harm we caused, or does it simply provide cover for continued destruction? These questions may seem abstract, but they touch on fundamental issues about humanity's relationship with nature. We drove the thylacine to extinction through ignorance and greed. We have the power to perhaps bring it back. But having power and using it wisely are very different things. Meanwhile, in the Tasmanian bush, the sightings continue. People keep seeing something that looks like a dog but is not a dog. Something with stripes and a stiff tail and a way of moving that does not match any known species. Is it the thylacine refusing to vanish completely? Is it wishful thinking and misidentification? Or is it something else entirely, something we have not yet explained? The Tasmanian ghost walks on, and we follow in its footsteps, searching for answers that remain just out of reach. From the forests of Tasmania, let us descend now into the darkest depths of the ocean. Let us explore the creatures that hide in the abyss, the monsters that turned out to be real. Chapter 8. Creatures from the Abyss. December the 22nd, 1938. The coast of South Africa near the mouth of the Chalumna River. A fishing trawler called the Nerine hauls its nets from 40 fathoms down. Among the usual catch of sharks and ordinary fish lies something extraordinary. A large blue fish dappled with white spots covered in armour, like scales, with 4 strange fins that look almost like stubby legs. Captain Hendrik Goosen has never seen anything like it, neither has anyone else alive. The fish is taken to the East London Museum, where curator Marjorie Courtenay-Latimer recognises that she is looking at something impossible. She contacts ichthyologist J.L.B. Smith at Rhodes University. Smith does not believe her at first. What she is describing cannot exist. The fish she's describing went extinct 66 million years ago, along with the dinosaurs. But when Smith finally sees the specimen, his reaction is immediate and overwhelming. The most beautiful fish I have ever seen, he later wrote, and one of the most important discoveries in the history of zoology. The coelacanth had returned from the dead. This was not a rumoured sighting or a grainy photograph. This was a physical specimen, a 5-foot-long fish that scientists could touch, examine and study. The coelacanth had been known from fossils dating back 400 million years. It was considered a transitional form between fish and land animals with lobed fins that moved in a walking pattern. When it disappeared from the fossil record at the end of the Cretaceous period, scientists assumed it had gone extinct with the dinosaurs. For 66 million years, that assumption stood unchallenged. Courtenay-Latimer struggled to preserve the specimen in the South African heat. The local mortuary refused to store it. A food refrigeration facility turned her away. Eventually, a taxidermist preserved what remained, but the soft internal organs were lost before Smith could examine them. Still, the discovery sent shockwaves through the scientific world. Headlines proclaimed the find one of the greatest in natural history. Newspapers called it proof that sea monsters could exist. If scientists could be so wrong about the coelacanth, what else might be swimming in the unexplored depths? A second coelacanth was not found until 1952, when one was caught near the Comoro Islands between Madagascar and the African coast. Since then, populations have been discovered in several locations throughout the Indian Ocean. In 1998, an entirely separate species was found in Indonesia, nearly 6,000 miles from the African populations. The Indonesian coelacanth differs in colour and genetics, suggesting the two populations have been separated for millions of years. The coelacanth story illustrates a crucial point about extinction and survival. The fish survived because it lived in exactly the kind of environment that does not produce fossils. Rocky underwater caves at depths of 500 to 800 feet, low oxygen conditions that discourage decomposition, volcanic islands that form and erode too quickly for sediment layers to build up. For 66 million years, coelacanths lived, died, and left no trace. Their apparent extinction was simply an absence of evidence, not evidence of absence. Could other supposedly extinct animals be hiding in similar refuges? The ocean certainly offers plenty of options. 95% of the deep sea remains unexplored. Hydrothermal vents support ecosystems that were completely unknown until 1977. Cold seeps on the ocean floor harbour communities of organisms that live on chemical energy rather than sunlight. Every expedition to the deep discovers new species. The abyss is not empty. It is teeming with life we have barely begun to catalogue. The giant squid is another example of a creature that seemed mythological until science confirmed its existence. For centuries, sailors told stories of the kraken, a massive tentacled beast that could drag ships beneath the waves. Scientists dismissed these accounts as exaggeration and superstition. Then specimens started washing up on beaches. Tentacles were found in the stomachs of sperm whales. Sucker marks the size of dinner plates appeared on whale skin. The kraken was real. We just called it something different. Architeuthis ducks, the giant squid, can grow to over 40 feet in length, with eyes the size of dinner plates and tentacles lined with serrated suckers. Despite its size and widespread distribution, the giant squid was not filmed alive in its natural habitat until 2004, when Japanese researchers captured footage at 3,000 feet depth. Before that, every specimen studied by science had been dead or dying, washed up on beaches, or caught accidentally in fishing nets. An animal that large remained essentially invisible to science for centuries. The colossal squid is even larger. Mesonicoteuthis hamiltoni can exceed 45 feet and weigh over 1,000 pounds. Its tentacles are armed with rotating hooks rather than simple suckers. Unlike the giant squid, which seems relatively passive, the colossal squid may be an aggressive predator. Very few specimens have ever been examined. We have no idea how many exist or what their behaviour is like in the wild. Something the size of a school bus with weapons for arms lurks in the deep ocean, and we know almost nothing about it. These discoveries fuel the imagination. If giant squids and colossal squids could remain hidden for so long, what else is down there? Could Megalodon have found refuge in the deep ocean, adapting to cold, dark conditions over millions of years? Could plesiosaurs have survived in some isolated marine environment, evolving to avoid detection? The possibilities seem endless. But the possibilities are constrained by biology. Megalodon was a warm water coastal predator. It needed abundant large prey and protected nursery areas. The deep ocean offers neither. Plesiosaurs were air-breathing reptiles that would need to surface regularly. They could not hide in the abyss forever. The coelacanth survived because it was perfectly adapted to a specific niche that humans rarely encounter. Not every supposedly extinct animal has such a niche available. Still, the deep ocean continues to surprise us. In 2012, researchers using deep-sea cameras captured footage of a megamouth shark, only the 64th specimen ever recorded. This 15-foot filter feeding shark was unknown to science until 1976. In 2014, a new species of beaked whale was identified from specimens that had been washing up on beaches for over a century, but had never been properly classified. Every year brings new discoveries, new species, new evidence that the ocean harbours secrets we have not begun to uncover. The most tantalising discoveries often come from the places where ocean meets land. Estuaries and coastal waters hide their own mysteries. The Mekong River in Southeast Asia is home to giant freshwater stingrays that can exceed 14 feet in length and weigh over 800 pounds. The Amazon basin contains fish species still being described by scientists. Lake Baikal in Siberia supports an endemic seal population that no one can fully explain. How did marine mammals end up in a freshwater lake thousands of miles from the ocean? Perhaps the most remarkable recent discovery involves not finding something new, but finding something old. In 2023, a group of researchers found evidence that the bowhead whale may live over 200 years making it potentially the longest-lived mammal on Earth. We have been hunting these whales for centuries, and only now are we learning basic facts about their biology. If we can miss something so fundamental about an animal we actively pursue, how much are we missing about animals we barely encounter? The lesson of the coelacanth is humility. Science is powerful, but it is not omniscient. Our knowledge of the natural world is incomplete and always will be. When we declare a species extinct, we are making a statement about our own limitations as much as about the species itself. We are saying that we have looked everywhere we can look and found nothing. We are not saying that nothing exists, only that we cannot find it. This does not mean that every cryptid is real or that Megalodon is hiding in the Mariana Trench. Extraordinary claims still require extraordinary evidence. But it does mean that we should approach these questions with intellectual honesty. We do not know everything. We cannot know everything. And sometimes the things we think we know turn out to be wrong. The abyss keeps its secrets. The deep ocean remains alien territory, more mysterious in some ways than the surface of Mars. What lives down there? What ancient lineages have found refuge in the darkness? What monsters await discovery in the cold, crushing depths? We may never know, but we will keep looking, because that is what humans do. We search, we question, we refuse to accept that the map is complete, and sometimes, just sometimes, the monsters turn out to be real. Chapter 9. When Myth Becomes Reality. Throughout human history, we have told stories about impossible creatures, dragons that breathe fire, sea serpents that swallow ships, giants that walk the earth, monsters that haunt the darkness at the edge of firelight. These stories served many purposes. They explained the unexplainable. They warned of dangers real and imagined. They gave form to fears that had no other shape. And sometimes, just sometimes, they turned out to be based on something real. The okapi was a myth until 1901. For centuries, European explorers heard stories from Congolese peoples about a forest-dwelling animal that looked like a cross between a zebra and a giraffe. Scientists dismissed these accounts as confusion or exaggeration. Then British explorer Harry Johnston obtained pieces of striped skin and eventually a complete specimen. The okapi was real. It had been living in the dense forests of Central Africa the entire time, unknown to Western science, but perfectly familiar to the people who shared its home. The Komodo dragon followed a similar path from legend to reality. Indonesian islanders had always known about the giant lizards that inhabited certain remote islands. They called them land crocodiles and ora, and treated them with appropriate caution. European scientists heard these stories and filed them under native superstition. Then, in 1910, a Dutch colonial administrator obtained specimens. The Komodo dragon, the largest living lizard capable of reaching 10 feet in length and bringing down water buffalo, was suddenly very real. The mountain gorilla was discovered in 1902 when a German officer shot two in the Virunga Mountains. Local peoples had known about these great apes for generations, but scientific descriptions required physical evidence. The same pattern repeated with the bonobo, not recognized as a separate species from chimpanzees until 1929, and with the giant forest hog first described in 1904 despite being one of the largest wild pigs on Earth. These discoveries share a common thread. Local peoples knew about the animals all along. It was only Western science that needed convincing. The okapi was never a myth to the Muti people who lived alongside it. The Komodo dragon was never legend to the islanders who avoided its hunting grounds. Indigenous knowledge systems had catalogued these creatures for generations. Scientific discovery simply translated that knowledge into a form that European institutions could accept. This raises an uncomfortable question. How many other creatures known to local peoples remain undiscovered by science? How many animals dismissed as folklore or superstition might turn out to be real? The history of zoology suggests that indigenous accounts deserve more respect than they traditionally receive. The saola, sometimes called the Asian unicorn, was discovered in 1992 in the mountains of Vietnam and Laos. This forest-dwelling bovine had never been seen by Western scientists despite being known to local hunters. It is so rare that camera traps have only captured a handful of images. No saola has ever survived in captivity. We know almost nothing about its behavior ecology or population size. An animal the size of a large dog remained hidden from science until 3 decades ago. The Laotian rock rat was another recent surprise. First collected in 1996 at a food market in Laos, This rodent turned out to belong to a family thought to have gone extinct 11 million years ago. Like the coelacanth, it was a living fossil, a remnant of an ancient lineage that had somehow persisted while all its relatives vanished. The Laotian rock rat had been hiding in plain sight, sold as food in local markets, while scientists believed its entire family was long dead. These rediscoveries challenge our confidence in extinction declarations. If a family of rodents can survive 11 million years without leaving a trace in the fossil record, how reliable is that record? If animals the size of cattle can remain unknown to science into the 1990s, how complete is our catalogue of life? The answer appears to be not very complete at all. Consider the ivory-billed woodpecker. This spectacular bird was declared extinct in the 1940s after its bottomland forest habitat was destroyed by logging. For decades it was considered gone. Then in 2004, researchers in Arkansas reported seeing one. Video footage was analysed and debated. Search teams combed the swamps. The evidence was tantalising but never conclusive. The ivory-billed woodpecker might still exist, or it might not. We simply cannot say for certain. The same uncertainty surrounds dozens of species. The Jamaican petrel, last confirmed in 1879, has been potentially sighted several times since. The night parrot of Australia, thought extinct for over a century, was rediscovered in 1990. The black-footed ferret was down to 18 individuals in 1987 and has been slowly recovering through captive breeding. The boundary between extinct and critically endangered is fuzzy and permeable. Lazarus species is the scientific term for organisms that reappear after being presumed extinct. The name references the biblical figure who rose from the dead. It is a surprisingly common phenomenon. Researchers have identified dozens of Lazarus species across multiple taxonomic groups: plants, insects, fish, mammals, reptiles, birds. Extinction, it turns out, is harder to verify than we thought. This does not mean that extinction is not happening. Species are vanishing at rates not seen since the dinosaurs died. Habitat destruction, pollution, climate change, and human predation have pushed countless organisms over the edge. The current extinction crisis is real and devastating. But within that crisis there are occasional miracles. Animals that survive against all odds. Populations that persist in forgotten corners of wilderness. Lineages that refuse to end. The Lord Howe Island stick insect provides a remarkable example. This large flightless insect was thought to have been driven extinct by rats, introduced to its island home in 1918. For 8 decades it was considered gone. Then in 2001, climbers on a nearby volcanic rock formation found a tiny population living beneath a single shrub. 24 individuals, the entire species surviving on a cliff face barely larger than a football field. A breeding program was established, captive populations were built up. Rat eradication efforts began on Lord Howe Island. Today thousands of stick insects exist in captivity, and plans are underway to reintroduce them to their original habitat. A species that was completely written off is now on track for recovery. The dead have risen. What does this mean for our search for monsters? It means that absence of evidence is not the same as evidence of absence. It means that vast areas of our planet remain unexplored and poorly understood. It means that local knowledge should be taken seriously even when it contradicts scientific consensus. And it means that hope is not always foolish. But hope must be balanced with realism. The coelacanth survived because it occupied a specific niche that protected it from detection. The okapi survived because the Congo rainforest is vast and impenetrable. The Laotian rock rat survived because nobody was looking for it in food markets. Each rediscovery had specific circumstances that enabled it. Not every rumoured creature will have such circumstances in its favour. Megalodon almost certainly is extinct. The ecological niche it occupied no longer exists. The prey base it depended on has transformed. The coastal nursery areas it needed have disappeared. No amount of wishful thinking can change these biological realities. The same logic applies to many other legendary creatures. Plesiosaurs could not hide in Loch Ness because the lake is too small, too cold, and too well surveyed. Bigfoot populations cannot exist in the Pacific Northwest without leaving physical evidence. But the thylacine, the ivory-billed woodpecker, various presumed extinct species in remote corners of tropical forests. Here the evidence is less conclusive. Here hope might still be justified. Not certainty, but hope. The possibility that something wonderful awaits discovery in the wilderness that remains. The monsters of legend are mostly just that, legends, stories we tell ourselves about the unknown. But occasionally, rarely, the legends turn out to be true. The dragon becomes a Komodo. The unicorn becomes an okapi. The living fossil rises from extinction to swim again in modern seas. We are not done discovering. The map is not complete, and somewhere out there monsters, real monsters. The beautiful, terrible creatures of a planet we have barely begun to understand are waiting to be found. Chapter 10. The Monsters Among Us. We began this journey with a question. What if the Megalodon shark never went extinct? What if that ancient terror still patrolled our oceans, waiting in the darkness below? The answer we discovered is complicated. Science tells us Megalodon is gone, has been gone for millions of years. The evidence is overwhelming. The ecological niche no longer exists. The fossil record falls silent. The bodies never appear. And yet we keep looking. We keep hoping. We keep scanning the horizon for that impossible fin. Because Megalodon represents something more than just a giant shark. It represents the possibility that our world still contains wonders we have not discovered, terrors we have not faced, mysteries we have not solved. We have travelled far in this investigation, from the warm prehistoric seas where Megalodon ruled to the cold dark waters of Loch Ness, from the frozen peaks of the Himalayas to the dense forests of the Pacific Northwest, from the eucalyptus groves of Tasmania to the crushing depths of the ocean abyss. Everywhere we went, we found the same pattern. Legends that refuse to die. Sightings that cannot be explained. Evidence that tantalizes but never quite convinces. The Loch Ness Monster is almost certainly not a surviving plesiosaur. DNA surveys have found no trace of unknown reptiles in the loch. The most likely explanation for Nessie sightings is a combination of misidentification, wishful thinking, and occasional deliberate hoaxing. But the sightings continue. People keep seeing something in that dark Scottish water. Whether what they see is real or imagined, the experience feels genuine to them. Bigfoot and the Yeti present similar puzzles. No physical evidence supports their existence. Hair samples and footprints have consistently turned out to belong to known animals or to be obvious fakes. The Patterson-Gimlin film remains ambiguous after more than 50 years of analysis. If large bipedal apes roamed North America or the Himalayas, we would have found definitive proof by now. The smart money says these creatures do not exist. But indigenous peoples have told stories about wild hairy giants for thousands of years. Cultures separated by oceans and continents describe remarkably similar creatures. Something in the human experience produces these legends. Whether that something is misidentified bears psychological projection or actual encounters with unknown primates remains an open question. An unsatisfying answer perhaps, but an honest one. The Tasmanian tiger offers a different kind of mystery. This animal definitely existed. We have photographs and film footage. We know exactly what it looked like, and according to statistical analysis of sighting records, it may have survived decades longer than officially recognised. The thylacine is not a cryptid in the traditional sense. It is an extinction event that might not be complete. The coelacanth proves that species can hide from science for tens of millions of years. The giant squid proves that enormous creatures can remain essentially unknown until we develop the technology to find them. The okapi and Komodo dragon prove that animals dismissed as legend can turn out to be real. These precedents keep hope alive for believers in more exotic creatures. If we were wrong about the coelacanth, why not the megalodon? The difference lies in ecology. The coelacanth survived in a specific niche, deep rocky caves that humans rarely encountered. The giant squid lives at depths we're only now learning to explore. These animals had refuges where they could persist undetected. Megalodon had no such refuge. It was a creature of the continental shelves, the warm, shallow waters, where humans have fished and sailed for millennia. It could not hide. This is the central lesson of our investigation. Survival requires more than luck. It requires the right conditions, the right habitat, the right food supply, the right balance of threats and opportunities. When those conditions disappear, so do the species that depend on them. Megalodon vanished because its world vanished. No amount of hoping can bring that world back. But the search for monsters is not really about finding them. It is about what the search reveals about us. We are a species obsessed with the unknown. We peer into darkness and imagine shapes. We hear sounds in the forest and invent explanations. We see waves in lakes and picture ancient reptiles. This is not weakness or delusion. It is the same impulse that drove us to explore continents, cross oceans, and eventually reach for the stars. Wonder is the beginning of wisdom, wrote Socrates. The sense that there is more to the world than we currently understand. The recognition that our knowledge is incomplete and always will be. The monsters represent that incompleteness. They stand at the boundary between the known and the unknown, reminding us that the map is never finished. And sometimes, just sometimes, the monsters turn out to be real. Consider what we have learned since the age of exploration began. Gorillas were fairy tales until 1847. Giant pandas were unknown to Western science until 1916. The platypus was considered a hoax when the first specimen reached Europe in 1799. Scientists thought someone had sewn a duckbill onto a beaver as a joke. The natural world consistently proves stranger than we imagine. Today, new species are being discovered at unprecedented rates. Not just insects and microbes, but vertebrates, mammals, primates. In 2020 alone, researchers described over 500 new species including frogs, snakes, fish, and even a new species of whale. The sixth mass extinction is happening, but so is a golden age of discovery. We are losing species faster than we can count them while simultaneously finding species we never knew existed. This paradox defines our moment. We have the power to destroy ecosystems that took millions of years to evolve. We also have the power to explore, document, and potentially protect what remains. The choice we make will determine what kind of world our descendants inherit. A world impoverished by extinction, or a world where mystery still survives at the edges of the known. The Megalodon is gone. We cannot bring it back. But we can protect the sharks that still swim our oceans, many of which face extinction within our lifetimes. We cannot confirm the existence of the Loch Ness Monster, but we can preserve the wild places where wonder survives, where people can still look into dark water and imagine dragons. We cannot prove that Bigfoot roams the Pacific Northwest, but we can save the old growth forests where such a creature might hypothetically hide. The monsters of legend may not be real, but the impulse that created them, the sense of wonder, the recognition of mystery, the acknowledgement that we do not know everything is real. It is one of the best things about being human. It is what drives science forward. It is what makes exploration worthwhile. It is what separates us from animals that accept their environment without question. Megalodon never went extinct in our imaginations. It swims there still, a 60-foot nightmare patrolling the depths of human consciousness. The Loch Ness Monster surfaces every time someone stares across dark water and feels the ancient thrill of uncertainty. Bigfoot walks through our dreams, leaving footprints that will never fade. These creatures are immortal not because they exist in the physical world, but because they exist in us. And every now and then the line between imagination and reality blurs. A fish thought dead for 66 million years swims up from the abyss. An animal declared extinct is spotted in the Tasmanian bush. A creature dismissed as legend turns out to be documented fact. This is why we keep searching. This is why we will always keep searching. Because the universe is vast and strange and full of surprises. Because the map has edges we have not reached. Because monsters, both real and imagined, remind us of something essential about our place in the cosmos. We are small creatures on a small planet in an infinite universe. We have been here for an eye blink of geological time. We have explored a tiny fraction of our own world and know almost nothing about what lies beyond. In the face of such vastness, humility is not weakness, it is wisdom. The monsters are waiting, in the deep ocean, in the misty highlands, in the frozen mountains, in the ancient forests. They are waiting for us to find them or to stop looking. They are waiting to be proven real or to remain forever in the realm of legend. What will we discover next? What impossible creature will emerge from the unknown to astonish us? What extinct species will return from the dead? What myth will become reality? We cannot know. That is the beauty of it. That is why the search continues. That is why the monsters matter. If you enjoyed this deep investigation into the creatures that refuse to die, please like this video and subscribe to the channel. Your support makes these detailed explorations possible. Tell me in the comments which legendary creature should we hunt next. The chupacabra of Puerto Rico, the Mokele Mbembe of the Congo, the sea serpents that sailors have reported for centuries. Every legend has a story. Every mystery deserves investigation. The monsters are waiting, and so am I. Thank you for watching. I will see you in the next investigation.